I'm Sienna Bose. Welcome to my channel, Learning Builds Life. Today we are going to talk about nomenclature, IUPAC, alkanes. Firstly, we will know the full form of IUPAC, which we call IUPAC. It is International Union of pure and applied chemistry. And about alkanes. Let's talk about alkanes a little bit, and then we will move on to the nomenclature. Firstly, alkanes are saturated hydrocarbons. Alkanes are saturated hydrocarbons. Our next point is alkanes consist of only single covalent bonds. Alkanes consist of only single covalent bonds. That means it is saturated alkanes consist of only single covalent bonds in their molecular structure. Molecular structure. No double bonds and no triple bonds. Our next point is, because of this, that alkanes consist of only single covalent bonds, it means they are saturated hydrocarbons, and it has no double bonds or no triple bonds, it is less reactive. It reacts very less. Otherwise called paraffin. Paraffin is used in candles. And lastly, there is a specific formula by which we can calculate the formula of each of the alkanes. That is a generalized formula. The general formula is CN H2n plus 2, where n can be equal to 1, 2, 3, 4, 5, 6, and so on. It is actually homologous. Alkanes are homologous. Now, since we've talked about alkanes, we can move on to the nomenclature and some examples of alkanes. Let's take a look. Firstly, we will have the N means number of carbons, basically, since you can see here. If N is 1, then the formula is C, because 1 carbon. And now if we calculate 2N plus 2 with 1, then 2 plus 2 into 1, 2 plus 1, 4. Its name is methane. It is methane. Now its structure is one carbon attached means bonded to 4 hydrogens. Next, we have N equal to 2. It will be C2, and as per calculations we have H6. This will be ethane. Structure is two carbons and 6 hydrogens. When N is equal to 3, then it will be C3, and let's calculate that, H8. That is propane. Let's draw the structure. Three carbons and 8 hydrogens. The main thing in making these diagrams is the carbon atom should be bonded on all 4 sides because its covalency is 4, and hydrogen has to be bonded only on one side because its covalency is 1. We have N equal to 4, which gives us C4. Then we have to calculate again, 2 and 4, 8 plus 2, 10, H10. This is butane. Now I will draw the structure. Four carbons and 10 hydrogens. And this was all the space was there, but there are many more. I'm doing till 12 carbons. So there is pentane, which has 5 carbons, hexane, heptane, 7 carbons, octane, 8 carbons, Then we have dodecane. It's 12 carbons. Undecane. That is 11 carbons. Nonane. That is 9 carbons. And decane. That is 10 carbons. So pentane is 5 carbons, hexane is 6 carbons, heptane is 7 carbons, octane is 8 carbons, dodecane is 12 carbons, undecane is 11 carbons, nonane is 9 carbons, and decane is 10 carbons. Now you may take a look at the board. Hope you enjoyed this episode, and please like, share, and subscribe my channel, and stay tuned for more videos. Thank you.